Hey yo, what's up guys? It's Brendan here, back with another video. So today we're going to talk about ionization potential, electron affinity, electronegativity, and polarizability. So, what do you say? Let's go take a look. So, what really is ionization potential?
The ionization potential IP of an atom or molecule is the minimum energy required to remove an electron from the gaseous atom or molecule in its ground state.
In multi-electron systems, removing an electron from an atom or molecule usually results in a cation in an excited state. A relaxation process is then necessary to bring that cation back down to its ground state. The relaxation process can either be rotational or vibrational, and it can release heat or produce light.
For ionization potential, as you keep removing electrons from the atom, the ionization potential will increase for each of the following electrons on the same atom. The general trend as you move across the periods is that the ionization potential will increase, and as you move down the groups, the ionization potential will decrease. However, there are some exceptions. When atoms are stable, they either have full or half-full orbitals. Unstable atoms have orbitals that have a single electron or one extra electron past the half-full orbital. These unstable orbitals are more willing to release its electron that makes it unstable, meaning that it has a lower ionization potential compared to the more stable atoms. And that is why there are dips in the trend on this diagram.
Ionization potential values are always a positive value, as it requires energy to remove the electron from the atom. And the ionization potential values are given in electron volts. The next topic is electron affinity.
The electron affinity of an atom A is the energy required to remove an electron from the negative ion, A- or anion, in the gas phase.
So electron affinity values can either be positive or negative. The value can be positive when the anion is more stable than the regular ground state atom, as it requires energy to remove the electron from the anion. The value can be negative when the anion is less stable than the ground state atom, and this means that it will release energy when the electron is taken off.
Do you know where you are, Mr. Gas? Mr. Noble Gas? Something just doesn't feel right. I feel unstable. The halogens have been trying for centuries to gain that extra electron and become an anion.
They gave an extra electron to everyone, including you, Noble. I'm truly sorry. The halogens have the full octet. There's nothing we can do.
It's been told that when the halogens become an anion, they are more stable than ever. But you, Noble, you aren't stable at all.
While the halogens are over there partying with their stable atom and full octet, us noble gases, we're here suffering, trying to make things right.
Mr. Halogen, there's someone here to see you. The general trends are that the noble gases and alkaline earth metals have large negative values, as the anions are unstable and want to release their electron. The halogens, however, are extremely stable, as they have filled their octet and do not want to release their additional electron, making the value large and positive.
Ionization potential and electron affinity values can only be measured for isolated atoms in the gas phase. They cannot be a measure for individual atoms within a molecule. The next topic we're going to look at is electronegativity.
Electronegativity is the relative ability of an atom to attract electrons to itself in a chemical bond. Electronegativity is a value to help individuals understand the molecular properties or reactivities surrounding the sharing or stealing of electrons.
Electronegativity also helps us define what type of bonds various atoms have with one another.
An ionic bond is the complete transfer of an electron. This occurs when one atom has a much larger electronegativity value compared to another. A polar covalent bond is when the probability of locating the bonding electrons are closer to one atom than the other. One atom has a slightly larger electronegativity than the other. A nonpolar covalent bond is when the probability of finding the electron can be found exactly the same between two atoms. This means that the electronegativity is equal between the two atoms. There are various ways to calculate electronegativity. Robert Mulliken proposed that electronegativity can be defined as the sum of ionization potential and electron affinity times a proportionality constant. Linus Pauling took Mulliken's theory and included the idea of bond dissociation energy and was able to convert Mulliken's electronegativity by using this formula.
So the general trend for electronegativity is as you move across the periodic table, the electronegativity will increase. And as you move down the periodic table, the electronegativity will decrease as the valence electrons are further away from the positive nucleus. The last thing we're going to look at is polarizability.
Polarizability is the ease of deformation of the electron cloud. It is a measure of how soft the electron cloud is.
So here I have a plastic bag. If we represent the plastic bag as the electron cloud, we can see that it's pretty squishy. This means that the electrons can flow throughout the entire plastic bag, and if we bring a positive nucleus beside it, the electrons can shift towards the one side, meaning that it becomes polar. With a smaller atom, like this ball I have here, it's not as squishy. It means that the electrons are held very tightly towards the middle of the nucleus. It means that the electrons can't shift towards one side or the other. It's all kind of symmetrical, and the electrons can't move around. So with that being said, polarizability increases with volume. Larger species become more polarizable. Polarizability also depends on electronegativity. The higher the electronegativity, the greater the attraction to the electrons, meaning it's less polarizable. And that's it. That's ionization potential, electron affinity, electronegativity, and polarizability, all in a nutshell. I hope you guys enjoyed. Make sure to like and subscribe, and I'll see you guys next time.
That's all, folks.